Welcome to part 3 of our VisRad introductory series. In this video, we'll be focusing on the subject of clipping target objects to create holes in our target system, as well as adding our material sample. Our goal in this video is to add our diagnostic hole cutout, our material sample cutout, and our material sample itself, all along the H14 line of sight leading to the backlighter. So first, how do we add our cutouts for our diagnostic hole and our material sample? Well, first we need to find the locations of these cutouts. To do that, we'll go to Line Target Intersection Points in the Tools menu, and we'll get a helpful little pop-up menu that lets us define a starting point and an ending point of a line of sight, and then we'll generate a list of all target object intersections between those 2 points. So for our starting point, we'll pick something far away in the reference system of the port H14 line of sight. So I'll switch to the reference coordinate system of port H14. I'll choose cylindrical coordinates, and I'll pick a Z that's sufficiently far away. I'll just go ahead and pick 30 millimeters. For the ending point, we'll just choose our backlighter, and we can go ahead and use its centroid because we already know that's lined up. If I hit update, 2 things happens. We see the line of sight is drawn in our target viewer, and we get the list of intersection points. We're drawing our line of sight from far away along port H14, and it ends at the backlighter. So our first intersection point will be the location of our diagnostic hole, and our second intersection point will be the location of our material sample. So we can look at this first intersection point and see that's in Cartesian coordinates in the reference system of the target chamber, which is a little hard to work with. So we can make sure our first point is highlighted and use the transformation button, and the coordinate transformation tool will pop up. This lets us translate coordinates from one coordinate system to another. So we're going to translate this position from the reference coordinate system of the target chamber to that of the hole realm, and we'll go ahead and make it be in cylindrical coordinates. If I hit update, this will be the position of our diagnostic hole cutout. So I can go ahead and right click here and choose to copy position variables, and we're all ready to add our cutout. To do that, we're going to use something known as a clipping volume, which is a bit like a target object. To add our first clipping volume, we'll right click on the thing that we want to cut out, which is our hole realm, and we're going to choose clip. This will give us the option to create a clipping volume, and for our diagnostic hole, we want a circle, so we'll use a cylindrical clipping volume. This will bring up a menu similar to the object parameters menu, but for clipping volumes. We just found this position of our clipping volume. So we know it's in cylindrical coordinates in the reference coordinate system of our hole realm. So I can go ahead and paste in that intersection point, the first from our intersection point list. And for the orientation, we just use our azimuthal angle of 288 from right here. And we want to flip it 90 degrees so that this cutout is facing outwards, perpendicular to the surface of our hole realm. For the size of our cutout, we're just going to use a radius of 0.15 and a length of 0.3. The length is a little arbitrary. You want to use something that's big enough to hit everything you want to cut, but not too big such that it cuts too much. For example, if I did something like a length of 2, we would cut 2 sides of our hole realm. So I had to choose something a little smaller like 0.3. If I hit OK and accept all this, we can see our diagnostic hole appear. And it's helpful to show clipping volumes when you're adding them, so you can toggle them on and off with this tool. Toggle clipping volume visibilities right at the top of our menu. And when I click that, you can see our clipping volume appear, our nice little cylinder. And now we can go ahead and add our clipping volume for our material sample. To do that, I'll bring up our intersection list once again, and we'll now use the second intersection point. We'll transform this to the reference system of the whole realm in cylindrical units, hit update, and copy this for the centroid position of our new clipping volume. And we'll just go ahead and right click on the whole realm and choose clip, and this time we'll use a box. We'll paste in the positioning information. But when we really think about it, all we really need is our azimuthal angle, because we want our clipping volume to line up with our sample that's right at the center of our whole realm. So we'll use a Z of 0. And for the radius of the clipping box, it can really be anything as long as we pick the correct size. So I'll go with 0.9 millimeters, which will put the center of our clipping box a little outside of our whole realm. And then finally, we do want to adjust the orientation with our azimuthal angle. And now we can go ahead and pick the sizing information. I'm going to go ahead and hit apply now, just to generate the box, just so we can size it with the box visible, which will help make things a little easier. So I'll go to the size tab, and we see an X, Y, and Z. This corresponds to the reference system of our whole realm. So we want to pick a Z that is the height of our sample along the height of our whole realm. Our sample is 0.8 millimeters high, so we'll choose 0.8 millimeters here. Now, if you can't tell what direction the Y is, you can just pick a value and hit apply. And you can see it's basically the length cutting across our whole realm. Let me readjust this quick so we can get a better view of what's going on here. Perfect. So yeah, you can see the Y is basically the length of the box cutting across the whole realm. So as long as we pick a Y that's big enough and clips everything we want to clip, that's good enough. So we'll go ahead and keep our clipping Y value of 3 millimeters. And then for X, all that's left is the depth of the cut into the box. We centered our box at 0.9 millimeters, and we want to cut in to a depth of 0.7 because we want our sample to be 0.7 millimeters from the center of our whole realm. So 0.9 minus 0.7 is 0.2, then we double it to get the width, which is 0.4. And I'll hit apply. And there is our sample cutout. Finally, we just add our sample. Let's get a view of our whole realm from above. So as I said, we want our sample to be 0.8 millimeters tall, and we want it to be centered at 0.7 away from the center of the whole realm, so right about here. So I will just go ahead and add a flat rectangle. In the reference system of the whole realm in cylindrical coordinates, we want it to line up with our clipping box. And to get there, we used a azimuthal angle of 108, which I'll go ahead and copy over. And we want this to be at the radius of 0.7, as I said earlier, and it's to be centered at Z equals 0. So for the sizing information, we want our height of the sample to be 0.8. And for the X, it's a little trickier because you can't just use 0.8. We want to find the length of this cutout through the whole realm. So if you just use some basic trig, you see it comes out to be about 0.7746. And if I hit apply, we generate our sample, but it's a little flipped. So I can just flip it by changing the orientation here of 90. And there's our sample. Let's go ahead and color some things in because it's starting to all blur together a bit. So for the sample, well, first we'll name it sample. I'll choose this to be an orange. And now it stands out. If I switch to solid gridding, you can see the sample fits in perfectly. And with that, we've basically added our line of sight. We can see the line of sight going through our diagnostic hole, hitting our material sample, and then continuing from the material sample to the center of the backlighter. Now all that's left for us to do is to connect our backlighter to the hole realm. Connecting the backlighter to the hole realm is a bit of a repetitive process, so I'll go ahead and save that for the next video. That video will be for people who want more practice with target objects. If you're comfortable with adding and editing target objects, feel free to skip the next video and go straight to video 5, where we'll be going over how to add a stock. I'll see you there.